Okay. So far in the previous class, yeah, it's focused. So far in previous class, we have seen about differential integrity constant. We have just started, right? And we saw what is reference relation and what is referencing relation, both, right? Now, we will look one by one. What are the constraint or say referential integrity constraint we have in reference relation, plus we have in referencing relation. First, try to understand the logic, say the concept, then we will understand, explore more with the help of an example. Fine. Okay. So we have started with the reference relation, right? In the previous example, we have seen like two relations. We took student and the course, right? We suppose A is the primary key and D is the foreign key of your student that we have used in the course table, right? The table or say the base table is your reference table, and in the table where we have used the primary key of other entity in our table as a foreign key is called your referencing table. So basically it is referencing to base or say the reference table. So far we have seen this quite well in depth. So now looking at the referential integrity constraint for your reference relation, right? So as I told you, basically when we have some issues, let's say we have previously a database of student in the course. What integrity or see integrity constraint means certain rules that we need to take care of while performing some actions over your database. For example, we do some insertions, we do some deletion, or we do some updation in your database. So we need to take care of things like our foreign key rules should not be violated. All those things we need to take care of, right? What are those rules violation on? We're gonna see that. First, we saw the reference relation, or say your base relation, right? The main relation. Okay. So in a reference relation, let's try to perform insertion to the table, right? We just saw with the help of an example before in the student table where we have the course information, right? So whenever some student is enrolled in some course, we're going to add on some details in for the student. Okay. So this is what a simple scenario we consider for this problem to understand this topic, right? Now, now let's consider for the first rule, right? Insertion in the table. Which table? The base table, say the reference table, right? This is our reference table. Okay, now let's say this is my university database. Now let's say some new student enrolled as a fresher in the first semester of first year. We're gonna put some information, say details of the student. For example, the name of or say the ID of the student is let's say S10. The name of the student is and every other detail so far we can fetch from the student. We're gonna store those information. This is what the list of all courses offered by my university or say the department, right? Initially when we are giving input in the database, right? So what happens, it's not like when student came to the university and instantly we provided some course and all, right? What generally happens, and obviously students information are first stored in the student table, and then after then some courses are allocated based on the seats or requirement or and every other constraint that university account into, right? So obviously it means what? We can give input in our table without violating any rule of your host table, right? So the input, when we give input in the student table, there is no violation of foreign key constraint here in the course table. So definitely insertion to the table will have no violation, right? Now coming up to the second, that is deletion. Right. Now see, when we perform some deletion, obviously, we need to take care of some small points. For example, let's say we have some student, right? We have a list of student, and now let's say this student S4 have finished his or her course. For example, it's a bachelor course, probably of 4 years have been finished, and now during his or her course we have obviously stored the information. For example, the student S4 were enrolled in data structure, say data science or some any courses for let's say 2 years with 100 credit and all. So obviously we are having some certain information of student here in the course table as well, right? So what will happen, let's say the student have passed, so graduations or say masters have been finished. So obviously we're going to remove the information of the data of student data from our database, right? Once we remove this information from the students in the base table, and see here, if we remove S4's information from the student only, then probably there will be some problem here. Why? Just thinking logically, the students say, when we search for the student S4, this student table will say, no, I don't have any such student here. But when I will search for S4 in this one, this table probably will say, yeah, I have a student S4 enrolled in this, right? So definitely this is where the integrity violation is happening here, right? So we need to take care of these things. So definitely when I remove some information from the student table, I need to take some action here as well. Why? Because this is the referencing relation. It is referencing, it is saying that S4 is there, but definitely in this table, S4 is not there, right? So for that, to avoid this violation, we have certain solution in our deletion operation, right? The first one is, let's understand them. And the first one is on deletion. On deletion, no action. We are taking no action, basically. No action is taken. What's the meaning of this? And this is, okay, what's the meaning of this one? Basically, when we perform some deletion on a referenced relation, record is restricted if foreign key violation occurs, right? So we will not allow this S4 to be deleted until and unless S4 should be deleted from here, right? So what this happens is, whenever there is some record related with some other table, right, it will your database SQL will say you have a relation for this particular record in this table as well. So you need to take some action in foreign key, or say the referencing table, only then you will be able to perform deletion here, right? So this is what restrictions we have. We can just put some restriction over a database, right? If there is a link with the table, probably you will not be allowed to perform direct deletion. And remember, by default this happen. This is just for data security part. We can just say, let's say some anonymous person gets hacked into a database and the person tries to delete some record, right? If we set it by default, no action will be allowed, no action will be taken, probably third person will not be able to delete your database, right? This is one operation, one solution you can have. The other is least favorite, on delete cascade. On delete cascade. Okay, what this cascade means? Basically it means what, on performing deletion on reference record is allowed, right? Deletion is allowed here, but database table, see, database management system will delete all the related referencing records as well, right? So this is what automatic operation, a trigger operation is happening here. Deletion is allowed, but all rows, or say tuples from referencing will be also be deleted, right? So understood, right? If you try to delete S4 and you have set in database student, say delete cascade, or say set cascade, right? You have set this operation on the student table, and when you try to remove S4, probably all the data which are linked with this particular table, particular tuple in any of the record, all the record will be automatically deleted, every record, right? So this is another solution for this one here. And the third one is on delete, probably you can set null, right? On delete, set null. So what happens if foreign key attributes allowed null, right? And foreign key attributes, basically where we're going to put the null here. Why? S4 is deleting, right? So S4 is here. So what you can do is you just set null here. Null means we have previously seen. Null values in foreign key says there is no relation of this row, this tuple with any of row in the student table, right? So this is what we can perform another action. And probably we know foreign key can have duplicate as well as null values here, right? Okay, so see what basically happens. There is a kind of order you need to take care of. For example, you are trying to delete S4. So you cannot do something like this one. First you delete S4 and then you are looking for S4 and set null. No, you go to the link referencing relation, you set null first here, and then you will be deleting this one here. Why? Because if someone, as I told you, if you are using what on deletion no action, probably if you will not set null here, it will not allow you to delete from here, right? So that's why first we set this to null and then it's free row, so you can delete this row very easily, right? So these are three basic action we can take, say the solution to avoid your violation rule here, right? First we saw for insertion, second we saw for deletion, and third one is for updation. See, we have seen deletion, obviously. So now you can think of updation here as well, right? In the updation, definitely we'll be facing some issues here, right? If you are updating some values, right, it's an updation. For example, this S4 student, you get to know that the S4 student's roll number is changed or some ID primary key value is changed. You get to know that, and S4 is related here, right? You change this attribute, say the value of this attribute to S10, but definitely once you have updated, it's a kind of new record, right? So definitely you need to take care of this one here as well, right? Where you find the previous value S4 and you update it to S10, right? If you don't do this one, right, on updation, right, basically on updation, you may need to maybe your database will not allow you to update these values by default, which generally used to happen, right? And probably on updation you can set cascade, right? On set cascade means whenever you update the values, it should be reflected here as well, right? Or probably on set cascade, or on this one on updation, you can set null values. How? You are updating this to S4 to the S10, you will find S4, you set it null and create another relation here for S10, right? So in this way, for updations as well, we can have the first one is no action, right? The second one is cascade, and third one is probably set null here. So these are again things you need to take care of, right? But the important part is, see, updation part will go on when you will perform SQL queries there, right? Deletion part you need to take care of. For updation, probably, yeah, you can have some question, but for deletion, probably you will having more questions there. Theoretically, you can design some question and perform what action probably will be taken into account, right? So these are a few points which are called your referential integrity for your referenced relation, right? Same goes for your referencing relation. Referencing relation. Now probably you can think of, if we perform insertion, into referencing relation, not reference. So far we have performed actions in this one. Now we will try to perform some action in this one here. For example, if you try to perform insertion in this one, so definitely and obviously it will cause violation, right? Because we have seen so far in the student, if you are having a max of S10 and if you try to insert some S20 values, definitely foreign key values will put some constraint here. It will restrict you from giving some values. Why? You are inputting that value which is not present in this one, right? So this we saw. So for insertion, again a restriction, restriction will be there on the insertion if foreign key violation occurs, right? So there is a restriction. See, you can ask, can we have the restriction of set cascade and set null and no? Why? Because you are inserting something in the referencing relation. You cannot say like you are inputting some values and you say that if we put S20 here and set null values. No, this is not a physical solution. This is not a practical solution, right? So simply when you perform insertion, referencing, say the your integrity constraint will basically stop you from inserting the values. That's it. But when you perform deletion, what do you think of? Should be there anything in this one that need to be take care of? You can delete anything from here. Definitely. If there is s10 present, okay, you can delete the values. It means what? There is a student, think of real life scenario. There is a student, right, who was enrolled in some course, and probably the student's course was changed to some other course. So definitely you can delete that value from here, right? So in this way, when you perform deletion, everything goes fine in your referencing relation. But when you think of updation here, right? When you think of updation, definitely and obviously you need to take care of all those things, right? It may cause a violation here, right? And it will try to restrict you from updation, right? Restrictions will be there. Why? The same scenario goes here. In the referencing relation, if you try to update any of the values, right? Let's say we talk about the foreign key, because we are talking about foreign key constraint, referential key, or say the foreign key constraint. If you try to update the values from, let's say, S10 to, you're changing to S20, updating. Same goes here. Is there S20 present here? No. So how you can enter the values in this here, right? So updation values will be again come into action and will stop you from inputting values, right? So if any of you have any doubt, for example, you want to know, you can just write in the chat. I will read and I will simply make you understand. Okay, so let's see an example, right? Probably better we will be able to understand with the help of example and how things go, right? Let's say there is a relation A and C and simply just taking, right? Let me write the values as well. This is A and C. Some values are there. Let's say 2, 4, 4, 2, 6, 2, 7, 6, 8, 14, 10, 10, some values. Okay. This is a relation I have just given you in which A and C are there. Right? Let's say I'm saying A is the key, primary key. Now what I'm saying is C is foreign key. C is the foreign key to A, which is to A means it is pointing to A here, right? So C is the foreign key here, right? It should not violate the rule because 14 is there, so it should be present here. Fine, every values are okay now. If C is the foreign key to A, with, remember this thing will be given in the question, with on delete cascade. On delete cascade. So the question is understood. C is the foreign key, right? Foreign key to A, definitely. With on delete set cascade, right? Remember the what set cascade is? Probably you need to delete those rows which are not in the primary key part here, right? Now the question is asking how many records should be deleted because of deletion of tuple or row. This one. If we delete 2 and 4, how many rows should be deleted? We are simply deleting this one here. And C's foreign key to A with on delete cascade. Understood the scenario, right? So now if I delete this one, see, if I'm deleting this one, it means what? There should not be 2 present in my this foreign key. Why? As I told you, if you delete the values of primary key here, probably you should be deleting the values of that particular near foreign key as well, right? So if you delete this row, 2 will be deleted. So 2 will be these and do. So basically you need to delete these values as well, right? Because it says there is some link of 2, but here it is saying there is no 2, right? So if you will delete these 2 values, right, along with this one, again see recursively, 4 should be deleted, right? Okay, fine, 4 we have deleted, no other 4s are there. But 6 should also be deleted here, right? Along with this one, due to this statement, we are deleting these 2. But due to this statement, we need to delete 6 as well. And see here, 6, yeah, it's there. So this 6 will also be deleted here, right? So, and any other 7, no, everything fine. 4, 6, everything fine, right? So on deleting this row, how many rows we need to delete? 3. 3 more rows will be deleted. Why? Because we have used delete cascade, right? Okay.
Sir, can you explain last step again?
Okay. See, in this one, as I told in the question, C is foreign key to A, right? With on delete cascade. On delete cascade means if you try to delete one row, probably you need to delete all the rows which are linked with your foreign key. 2 is linked with your foreign key, right? So when you delete this one, as the question says, what will happen? You need to see the primary key part here. If you're deleting 2, then in the foreign key, all the values which are referencing with the help of 2 should be deleted. For example, see this one. This is saying that, yeah, 2 is related to 4 of your primary key. But this table is saying I have no 2. So this should be deleted here. The same goes for here as well, right? But you have deleted these 2 rows because of this one, right? Now again you need to say you have, when you delete 4 and 2, the same goes for 4 also. It will say that there should not be any row which is referencing to 4 in the foreign key. So this is okay, we have already deleted, there is no other 4. Now see at this one, it is saying 6 should also be deleted. Now we need to check where is the 6. Okay, we found 6 here. So if we delete this row, definitely 6 will also be deleted, and we need to delete this as well. When we delete this, it is saying that 7 should also be deleted. We need to see like where there is any other 7. No, so that's fine. By deleting this one, it is not affecting any other row. So in total, due to this statement, we need to delete this, this, and this. So total of 3 rows will be deleted. Okay, so someone from the referencing table, can we directly delete the whole record rather setting it to null? See, in your referencing table, right? In the referencing table, you are saying that can we delete the whole record? So complete. If you are saying that you want to set this to null, right? As I told you, see here on the deletion, do we have any restriction? No. If you will simply delete the course, it probably practically means the university have stopped offering some course in some department, or say right now university is having no course to offer to the student, right? So probably if you delete, right, can directly delete
So
the
not this one.
oops,
Uh, in the previous one, the upper topic which we were discussing, the referred relation. In the deletion, you told कि हमें null करना पड़ेगा. Suppose we are deleting from a record from the referred table,
yeah,
and then from the referencing table हम उसे null करेंगे foreign key को.
yeah,
So instead of setting it to null, can we delete the whole record from the referencing table?
definitely it's your choice. As I told you, if you are deleting this one to null, right, just think of real life scenario. Probably you can set null or you can delete the whole row. If you are setting null, what you can say is probably you might be interested in using this row in future. That's why you are just simply retaining this table here. And if you really not want to use this one row here, you can delete this one. If you delete, you need to again set a values for the student, those who will again enroll in some course,
Okay, sir, got it. Thank you.
right? So obviously this is situational based, as if you think of any action you can perform, any of you delete or set null will not violate any of your foreign key constraint, right? So these are referencing relation points, and probably you have understood this question here, why we have deleted 3 rows. Okay. So, let me give you some another example. Let's say we have our A, B, C, this one here, and there is S, D, and E. AB is my key. You need to think of here. AB is my key, primary key here, right? D is okay, the key of this one, but I'm saying E is referencing to key AB. This AB is not a simple attribute. This is a composite attribute, right? We have seen in a candidate key, if we have more than one attribute, this is your composite attribute. I'm saying that E is the foreign key and pointing to AB. candidate key of this one. Is this operation allowed here? Is this operation allowed here? What do you think of? See, in this one, we saw A is the key, C is your foreign key, and the single attribute is pointing to this one, primary key. But always remember, when we have this key, the foreign key, this is what your simple key or the single key, simple key here, single attribute, right? This is foreign key. How you can say that? As we have seen, AB is collectively a candidate key. We say E is pointing to this part here, right? It's not feasible because we are saying that A and B together can identify C. We are not saying only A can identify C or B can identify C. But here, if you are taking E as a foreign key, it's saying that E is pointing to A and B both, right? So when we have, there is attribute mismatch, like number of attributes in this case here, right? When we have such type of scenarios, right, you won't be able, see, it will not allow you to delete something, not allowed here. You will not be allowed to do this one, perform the actions.
So, but can we have EF as a foreign key?
Yeah, obviously you can have that. Think of,
Okay.
right? Okay, so far we have seen one example. With the help of example, we have seen our referential integrity constraint here, right? And with this one, probably we have finished this one.